Welcome back, everybody. Today we're going to continue Chapter 4, our chapter on congruent figures. And in this lesson 4.2 and our next lesson as well, we're going to focus specifically on congruent triangles. Basically, we'll show you a few shortcuts for proving triangles congruent. Okay, 4.2 is triangle congruence by SSS and SAS. We'll explain what the heck that means in a few minutes. Objective today is to prove triangles congruent using SSS and SAS. Here we go with that. So let's start off by introducing those shortcuts to you. And to kind of show you why the first one works, let's do this. Let's take a triangle, and I'm going to make a copy of all three of its side lengths. And then what I'm going to do is I'm going to mix those copies up. I'm going to spin them around, so essentially I'm going to try to change the angles on them. I'm leaving things the same length, but let's put this triangle back together, see what happens. And what I want to see is, do I still have two congruent triangles? Can I still take this triangle in blue and match it up and lay it on top of the triangle in black? If I can get my angle just right, looks like I can. Yep, so it looks like we still have congruent triangles. Let's do that one more time just for the heck of it. Again, what's happening here is I'm taking copies of the side lengths. So my sides are the same length here. I'm mixing them up, and I want to see is when I put this back together, do I still get the same triangle? Do I still get two congruent triangles here? And when I put it back together, it looks like I do. We can again get that angle just right. Yep, there we go. Okay, so once again, I tried to mix things around, but since my side length stayed the same, I was left with congruent triangles. So that's the idea behind our first shortcut, the side postulate, or we'll abbreviate as SSS. It just says that if three sides of one triangle are congruent to three sides of another triangle, then the two triangles are congruent. Okay, so for example, if I have two triangles with side, and side congruent between them, I know that the angles are congruent. I kind of get that for free. I know the entire triangles are congruent. Okay, so how is that a shortcut? Well, in the previous section, if we want to prove that two triangles were congruent, we had to show that all three of their sets of sides were congruent and all three of their sets of angles were. Okay, basically it's a shortcut because if we can prove the sides are congruent, we get the angles for free. And let's do something similar to kind of show you our next shortcut. Let's take two triangles, or let's take a triangle, and let's say I'm making a copy of one of the sides, one of the angles, and another one of the sides. Okay, so I essentially have side, angle, side. So if I copy that, what I want to think about is what are my possibilities for this third side and the other angles? Well, if I go to fill in this last side, really I don't have an option for what this angle can be. I have to point it at the end of the first side. And then same idea, I really don't have an option for what the length of the third side can be. I can't make it shorter. I can't make it longer. It's got to reach this side. Okay, so essentially if I give you the side followed by an angle followed by a side, I'm giving you the whole triangle. That triangle is determined. We're going to call that idea the side, angle, side postulate, or SAS for short. It says that if two sides in the included angle of one triangle are congruent to two sides in the included angle of another triangle, then the two triangles are congruent as well. Okay, so again, if I have side, angle, side, where we'd say that angle is included between the two sides we're giving you, that just means between, okay, then the triangles are congruent. We get the other side, we get the other two angles for free. All right, so let's take a look at how we can use those shortcuts. Problem 1 says, would you use SSS, so as in side, side, or SAS, as in side, angle, side, to prove the triangles are congruent? If there's not enough information, write not enough information. So what we'll do is we'll give you a set of triangles with some information on them, such as angles marked congruent or sides marked congruent. And we want to determine, can we determine if these triangles are congruent, and if so, what shortcut are we going to use? All right, this is probably the most straightforward example where I'm given all the info that I need. Okay, so I have a set of sides marked congruent for me with a single tick mark, followed by an angle mark congruent with a single arch. followed by another set of sides marked congruent, okay, with the double ticks. Okay, and this is laid out correctly. We have the angle between the sides. We have side angle side and side angle side for two triangles. So for this one, I'd be able to say yes, they are congruent. All right, by, we could say SAS. Okay, let's do a few more of these together here, then we'll try a couple on your own. Here's an example of one that actually doesn't work. Let's take a look at why. Same idea, can we use SSS, SAS, or do we have not enough information to prove these congruent? Now this one, we're given some stuff. We have one set of sides congruent. We have a set of angles congruent, and another set of sides congruent. Okay, but notice how these letters are kind of laid out for us in this one. Triangle on the left, I have side angle side with that angle between those two congruent sides. Whereas the triangle on the right, I don't have that. I have angle side side or side side angle, not the same thing. What I can't do with these shortcuts is I can't say side, angle, skip an entire side, skip an angle side. I've got to keep things in order. Okay, so with these two, they may be congruent, but we don't have enough information, so we'll just say not enough info. Okay, so things didn't work out right to use either of our shortcuts. Let's take a look at one more problem together. And this one's a good example of the type of problem solving you'll need to do with these questions. So with C, again, we have two triangles together. We have some information about them, and we want to see which of our shortcuts, if any, can we use to prove these triangles congruent. Okay, we've got a set of sides. We have a second set of side. And we're not actually given any other sides or angles. But what I have here is I have two triangles that line up along the same side. Okay, they share that side. They're next to each other like that. Anytime that's the case, we know we have another side congruent. Okay, so I have a third S. That's all three sides. Therefore, I can say yes, they're congruent by SSS. Okay, there's a few examples. I believe there's three more, D, E, and F. Why don't you do this? Pause the video, try to work through those, come up yes or no, are they congruent, and if so, how do we know? And then hit play and we'll quickly run through and check your answer for you. All right, running through D, let's take a look at what we have. We have one set of sides. We have two sets of sides. And that's all we're given explicitly. Okay, but with this one, notice these two triangles meet in the middle here. And we have a set of vertical angles. Okay, I know that vertical angles are always congruent, therefore I do have a set of angles. So by side angle side, I can say yes, these triangles are congruent. All right, running through part E next, let's see what we have. We've got a set of sides. We have a set of angles that were given. And then just like a few examples ago, my triangles share a side here. So I know that will be a second side. So again, we have side angle side, side angle side. I can say, yeah, yes, these two triangles are congruent by SAS. All right, let's run through the last one here quick. I'm going to say right off the bat, yes, this one works. Okay, by, let's take a look. Now, it looks like there's actually two ways we could prove these congruent. I do have all three sides, so we could say side, side, side. Now with this one though, I can't use side angle side, because again, let's take a look at how these two angles fall. Notice on the left are angles between the side lengths with 2 tick marks and 3 tick marks. On the right, it's between the side lengths with 2 and 1. Okay, those aren't in corresponding positions. Okay, so I can't actually use side angle side. I can only use side, side, side for this one. A little tricky in that way. Again, with those angles, pay attention to kind of how they fall between those sides. Okay, one more type of question we're going to look at, and this is basically the same thing, just kind of looking at it through a different perspective. Problem 2 part A says, what other information do you need to prove triangle DEF is congruent to triangle FGD? So as we have two triangles and we're given some information, let's see here. We have EF is congruent to GD. That's one side. Like we've seen a few times now, our triangles share a side. So that will be a second side. And that's really all we're given here, two pieces of information. Now both are shortcuts, whether they're side, 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 or side, angle, side, needed three pieces. So what this question is asking for is what other information could we use if we were given that to prove these triangles congruent? Okay, there's actually a couple answers to this one. One would be if I knew that ED was congruent to GF. That'd be a third side. So again, if I had ED congruent to GF, I would have side, side, side. And I'd be able to prove these congruent by side, side, side. All right, or what else could I have? Again, focusing on those original two sides in blue. If I had the angles between the sides, such as here and here, then I would have side, angle, side on both these triangles. Okay, so in other words, if I knew that angle EFD was congruent to angle GDF, then I'd be able to say they're congruent by side, angle, side. Okay, so again, we weren't given enough information to start this one off, but if I had either of these two, then we'd be able to say they're congruent. Okay, part B is the same idea. It'll give you some information. You need to come up with what other information would allow you to say they're congruent. Why don't you take a minute, pause the video, give it a shot, and then hit play to check your answer. So again, in B, what other information we need to prove triangle LEB is congruent to triangle BNL? Let's take a look at what we have first. We have an angle that's given to us on both these triangles. We have a side that they share. So we have sides. And as far as what else we need, well, if we only are going to do it with one other piece of information, what we need is that this side LE is congruent to the side BN. That would be a second side, and that would set us up as side, angle, side. So what we're looking for here is LE is congruent to BN. Whoops, it's supposed to be an N. We'll say that's an N. There we go. Then it would work by SAS. Fix that up a little bit there. All right. All right, there you go. There's our side, 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 and side, angle, side shortcuts. Okay, we'll actually throw a few more shortcuts asking in the next lesson. Okay, for now, you can use those, start cranking through the homework. Like usual, if you get stuck, let us know. We'll be here to help you out.